Afternoon, good evening, or good night, wherever you are, and welcome to this introduction class or to getting started class on Microsoft Service Fabric. My name is Alex Mang, and it is my pleasure to welcome you and be your host for roughly the next hour or so. As Anthony already mentioned, I'm one of the Passion Azure MVPs. Also happen to run a company based in Transylvania, to be specific, and also I'm a trainer for Agility. Now, because I'm based in Transylvania, that's probably another way of saying that whenever I'm not writing articles or blog posts or don't deliver webinars or even trainings for Agility, I'm hunting down vampires, which of course is just a joke. Now, in today's talk, I have no idea who guys you are, but my expectations are, just like the poll or the reveal, are that you guys are architects or developers or IT pros who happen to have some experience or maybe no experience whatsoever with Azure. And that's awesome. That's okay, because I'm pretty sure in your own organization, in your own team, and throughout your peers, you're probably considered a superhero because you know so much. And let's face it, as IT guys, we more or less are always considered superheroes. And that's great. So the agenda for today will cover microservices. We'll cover Service Fabric cluster, and we'll also discuss a bit about application packages and Service Fabric packages. But before we go so far, I want to talk first and foremost about my original days with Azure. Now, because I'm not working for Microsoft, I'm only a Microsoft MVP, I do get a pleasure and the benefit of working with so many customers around the world. And ever since we started with working with Azure, which was roughly back in 2010, we had a plethora of different customers throughout the world, especially throughout Europe, from financial corporations focusing mostly on security rather than performance, or corporations which just wanted to make sure that their performance would get increased when they publish their applications up in the cloud rather than on premises. Now, besides that, we also had to deal with so many other scenarios, really cool apps. I'll be honest, really, really cool, interesting apps. But at the end of the day, at some point, after a few years with running and working with Azure, I ended up asking myself a question. Now, back then, we only had a single compute service, which was called Hosted Services. And later on, they renamed that and they rebranded it to Cloud Services, which was pretty cool, pretty nice, pretty awesome. Now, you know what? The problem or the confusion appeared when there were so many extra services. Now with IaaS, with virtual machines, it was pretty clear that they wanted to offer you a way to have more responsibility and to gain more access to the underlying virtual machine of the platform. Awesome. But then they had another platform as a service offering called websites and mobile apps, which were rebranded later on to web apps and mobile apps. And after that came in virtual machine scale sets and API apps, basically app services, the entire umbrella of application services. And later on came Azure Container Services and Service Fabric. And then we also nowadays discuss about serverless, which covers logic apps and Azure Functions. And nowadays we also have managed Kubernetes containers and Azure Container Instances if you just wanted to test one single container and this and that. And there are so many it's such an overwhelming number of different computing services that you end up asking yourself, why do I even care about all of these? And you know what? It's just been a few days that I ended up and I came across this tweet from Scott Hanselman, which basically pretty much covers, if you really think about it, software development nowadays. Like back 20 years ago, when you were twiggling with a new application and a new programming language, it was mostly a Hello World app, which was a basic app, and that was it. Nowadays, a basic Hello World app is a cloud-native distributed containerized RESTful microservices-based ARM v7 with Kubernetes Hello World as a service application. Sounds complex? Well, even though it does sound ridiculous at the beginning, I will tell you something. I'm one of the believers that the canonical or the example of best practices within a Hello World app should probably be canonical. In other words, everybody nowadays wants to publish their apps in Azure for one of the main reasons of either have high availability, either have reliability, either have disaster recovery, or just increase performance or whatever the case. But basically, at the end of the day, it's about business continuity. Now that's it. So if you end up implementing best practices and this good design patterns at the beginning or the inception of your new applications, you're pretty much guaranteed that business continuity will be part of your overall architecture and of your overall journey and the overall application lifecycle of your business and your obviously applications. Now, why do we even care and why do we even talk about microservices? Well, thinking about traditional applications, there was always a different and a big set of problems, of headaches. It was difficult to upgrade individual components. Whenever you were doing a scale out of your application, you were basically cloning the entire set and the entire set of tiers from your application, whether that was the web tier, the API tier, or the data tier. Altogether, they were more or less cloned into multiple instances. Having data schema contracts were so difficult to be enforced throughout different application versions. And whenever you were basically enforcing them, you're only making it more difficult to actually develop the application. Ever had the server Patch Tuesday? Well, that equaled application downtime. And in order for your application not to be down for the period of time, you had to have so many different instances. Then whenever you were doing a new deployment or a scale out of your application or even a scale in, the underlying hardware usage was so tightly coupled to the application instance, and honestly, it was completely irrelevant. There is no way basically to individually scale a single component of your application, say the API, because maybe our application is mostly used by mobile applications rather than web apps. Now, with traditional application servers, you usually had a component which was your web server, whether it was an Apache web server or IIS, whatever the case, doesn't really matter. Then you had a set of scheduled jobs which were doing the entire background task and were basically the heavy lifters of your application. A data feed service may be optionally there. A message queue, basically just a way for your system to communicate from your front ends to your back ends and back again, and maybe a web API or a REST API, RESTful service, again offered by IIS or Apache or whatever the case. And all the fact that all of these services were tightly glued to the underlying operating system feature is absolutely not good. But this is how your traditional application server looks like. Now, in microservices, this changes dramatically. Specifically, we no longer have a single big hardware or virtual machine to run all our application as a single slot. We have individual small components. Now, this small components actually is quite a lot of conversation going on around the fact, what is a microservice? How far do you decompose an application when it comes to decomposing monolithic traditional apps into microservices? And then again, the question is, what do you consider a microservice? Now, if you consider, and if we take the definition of a microservice that it has a single responsibility service, just like with your bound context and domain-driven development patterns and anything like that, your microservice should be something which is independent from anything else, but enforces a schema when it comes to data contracts, to data being moved around from one service to the other. And in this diagram over here, we have a number of different services colored differently in hexagons, running in different nodes of a cluster. Obviously, a cluster, just like any other cluster in IT, represents a farm of different nodes, where the nodes should be individual hardware or virtual components. So design is such a matter that if one node fails, the overall cluster is still up and the application should still be up. Now, when it comes to service healing, what Service Fabric promises, more or less, is that it will always copy your application from one primary to at least two secondaries, which just hang around, do basically more or less nothing. But if for whatever reason the node where your primary is ever going down for whatever unknown, unexpected, or even expected reason, your secondary, one of your secondaries will be promoted to a primary, and now your application is still running with almost no downtime whatsoever. Now, obviously, you will lose the down node, so a new secondary has to be created on a different node somewhere else, and so is it required for the other services which had either primaries or secondaries on that same node which has fallen. Now, again, you see we still have one primary, at least two secondaries. That's awesome. And it's also Service Fabric's responsibility to spin up a brand new node to make sure that it always has the minimum number of desired nodes designed by you as architects, developers, IT pros, and so on and so forth. As soon as the node is available, it's also Service Fabric's responsibility to make sure that it balances and evenly balances the entire set of services and microservices basically throughout the cluster. So again, it will just take the secondaries and the primaries from all the different nodes, and it will just make sure that everybody uses the same number of resources, more or less, evenly distributed across your cluster. Now, there is a concept of an update domain and a full domain in Service Fabric, and I will get to it just in a second. Basically, with update domain, or upgrade domain, very commonly called like that as well, the idea is that whenever you run a new version of any microservice, it doesn't have to be the entire app. Only a single microservice gets updated. It can get updated. You're publishing a new manifest. And with that manifest, you're basically specifying what is the version of my microservice, of that underlying microservice which I'm updating. When it comes to updating the application, by default, you will have a number of upgrade or update domains. Now, those domains basically are grouping together all your nodes into 1, 2, 3, whatever number of domains you have. And it basically means that when you're updating the app, rather than just updating everything from scratch, from ground up, and thus making your application, or at least that microservice, unavailable, you're just upgrading those nodes which are part of the same domain. So in this diagram, because we have 6 different upgrade domains and 6 different nodes, each one node which contains that microservice will be individually updated one by one after the other, and so on and so forth. Had we had 3 different domains, you would have 2 nodes which would simultaneously get the updated version of the microservice. And again, it's also Service Fabric's responsibility to make sure that if for whatever reason the service upgrade didn't go through as expected, it will just recover to the correct version. Now, when it comes to increasing the scale, you're basically just increasing the number of nodes. And that means you are adding, in this case, 2 extra nodes, like in this diagram. And again, it's Service Fabric's responsibility, just like I mentioned earlier, to evenly distribute across the entire cluster the number of services on all of the nodes available. Now, as a definition of a microservice, because we focus so much on this term, you should think of single responsibility, or SOLID, which is an acronym. S in SOLID stands for single responsibility. Basically, the idea is that you should run a single thing, something which executes a single domain, a single bound context, like similarly to your domain-driven development. The cool part about Service Fabric, though, is that when you're developing a new application, you can choose whether your service will be a stateful or a stateless service, and I will get to that later. But on top of that, or besides that, you can also create stateless executable programs, basically an exe file. Do you already have an exe file which represents your app? Awesome. That exe file can actually be a single microservice. Now, obviously, there will be a lot of debate whether the exe does represent a microservice. Does it only have one single responsibility or not? But at the end of the day, this is a great way to simply implement a lift and shift scenario using Service Fabric. Literally, you're just taking your executable file, which represents maybe a monolithic application, and it will run in Service Fabric. So even though it doesn't have statefulness and any other benefits, it still gets the benefit of having a primary, a secondary, of having a managed upgrade scenario, a managed recovery from a failure, hardware failure scenario, and so on and so forth. Executable programs, at the end of the day, are just console application or self-hosted web servers. Think of Kestrel, think of Katana, think of any OWIN for your ASP.NET applications, or it can just be whatever you're building for a task-appropriate framework or language. it always has, the microservice will always have independent code, independent configuration, and its independent data. So from one service to the other, there shouldn't be any conversation or any sharing of anything in terms of configuration code and data. Now, there's the concept of a cluster, and they already mentioned clusters a few times. But here's the thing. Remember at the beginning of this webinar when I was mentioning that Azure has a plethora of different computing services? Azure Service Fabric happens to be offered as a Service Fabric cluster offering, as a computing offering in Azure as well. You just go to your Azure portal, click on the New button on the left-hand side menu in the hamburger, type in Service Fabric. A Service Fabric cluster option will appear. You select a few options, click Create, and you're done. And you basically have an underlying infrastructure based on the virtual machine scale sets, which makes sure that on top of those, Service Fabric runs and the platform itself runs in a highly available and reliable manner. Now, as a cluster, the idea is that, as I mentioned, it runs on top of the Service Fabric skill set, but also the load balancers and the virtual networks, which make the entire communication work together, will already be embedded part of your resources within Azure. On top of that, Service Fabric is Polynimbus. So whilst the cluster will run indeed in Azure, Service Fabric as a term is nothing else than a platform. It has its own SDK, which means that you can just download the SDK and use the best IDE ever, Visual Studio, obviously, and make Visual Studio your IDE for developing stateful, stateless, or whatever other kinds of Service Fabric application. But it doesn't have to be like that. In other terms, you can just install the runtime for Service Fabric on premises. And once you install it on premises, you're basically assuring that you get the entire orchestration benefits of Service Fabric, but inside your own organization. Now, your clusters, they can be whatever you want. And I even suggest that after this webinar, you open up your favorite web browser and your favorite web search engine and search for Service Fabric implemented and designed to run on x86 or 64-bit boards similar to the Raspberry Pis. Why? Because indeed you can create a cluster with very cheap boards as well, and they will run Service Fabric, and you'll have a cluster of cheap boards which automatically do fault detection and upgrade detection and manage and orchestration and everything else. And on top of that, you can install Service Fabric not only on premises, but even in other clouds, even in AWS. And yes, Service Fabric can thus be a first-class citizen in a number of VMs running inside AWS. Now, Service Fabric is also cross-platform, which means that you can run Service Fabric both on Windows and on Linux distributions, which is pretty awesome, especially for the scenario where you want to use very cheap boards or don't want to take on the hassle of license management and this and that. Service Fabric always comes with a managed service dashboard. It can be your cluster managed service dashboard in terms of Azure, or it can just be your Explorer, the so-called Explorer, which is at the end of the day the same dashboard, but which can run inside your own runtime on premises, for example. And inside the dashboard, you will see all your available nodes, any warnings, any very detailed telemetry data from your applications which are running. What are the defined application types? What are the service types? You can upgrade applications, and you can even simulate right from within the dashboard what would happen if a node would go down. You just right-click the node from the dashboard, you say pause it for whatever time, restart it, stop it, do whatever you want, and thus you will see a node being completely deprovisioned from your cluster and the new one be created on top of that. And your application will still be running, no problem. And that's the beauty about using Service Fabric. Now, as I said, it's a system health. The dashboard is just a system health. It allows you to activate, restart, deactivate Fabric nodes, via application versions and images, and a lot of other things. The most important part, if you ask me, is about the telemetry data which Service Fabric gathers from your application and which is readily available as metrics and everything like that right within the dashboard. So you basically can check not only the health of your cluster and of your nodes, but also the health of your application. Is it running? Is it not running? Here in these images, it just shows you whether your on the left-hand side whether your node is active or not. And in this case, it's already an active node, which doesn't have any services running on top of it. But you can always, from the context menu, just choose to deactivate it as a pause, as a restart, or remove any data which runs inside that node. On the right-hand side, though, you'll see the health of your cluster. Are there any errors? Are the errors part of the nodes because maybe the nodes are unhealthy, or is it because of the application? Maybe the application has defined within its manifest that it has to run on a minimum number of nodes, and that number of nodes isn't available. Maybe the application has a service which isn't responding, and then it, again, Service Fabric will kick in, and it will just make sure that the application will be in a healthy state by restarting things, by moving services around in other nodes, and this and that. And if nothing can be done based on the manifest and the policies you have defined, then obviously you will have to manually kick in and make the appropriate settings. Now, there is a concept of a node type within a cluster. The idea is that whenever you spin up a new cluster in Azure, you'll have to specify how many node types do you want to configure and how many instances will you have of each node type. The idea of having multiple node types is to basically configure the more juicy machines, so to say, which will be available for those services which will require more computing power. Maybe there's some cryptography algorithms which you have to run through within one microservice. And for that, you supposedly will need more CPU power. Maybe there's another service which handles graphics and which will just require more memory. Maybe there is a service which just moves a lot of data around through the network, and that service will require a larger number of network interface cards to be connected, so it has better network connectivity, higher bandwidth, and this and that. Now, configuring multiple node types allows you, when it comes to configuring your cluster, to specify how many instances do you have of each node type. In this particular example over here, because we're still designing our application with the free tier kind of canonical example, where you have a web tier, a middle tier, and the backend tier, we do decompose the application, but the front end will still have multiple microservices be deployed in smaller web front-end nodes, whilst the API, because it requires more power, more computing power to run its business process, will be deployed in more juicier, more powerful D4, V2 compute optimized service nodes. Now, when it comes to auto-scaling, the load balancer, which is actually part of your virtual machine scale sets, will handle anything in terms of scaling out or scaling back in. That is horizontal scaling. Basically, just copies your data to a new VM and another VM, and it orchestrates part of the virtual machine scale set offering in Azure, the entire nature of configuration, application deployment, application discovery, and VM discovery, part of the cluster, and so on and so forth. Now, again, when you scale back in, nothing easier to do than that. Just specify that you need a smaller number of instances, and it's done. And you can even configure auto-scaling policies, which will automatically look at a schedule, look at the number of CPU, the CPU usage, or at the memory usage, and do those policies automatically based on the node types even. If you think about availability sets, and this might be something you came across before, here you just have a basic image of a rack. Now, within this rack, you have multiple nodes, multiple servers, stacked one on top of the other. But then there's a single point of failure in each of these racks, and that is, number one, the switch, which has the white cables coming out of it, and number two, the power unit. The power supply or the power unit, again, if it fails, will make the entire rack go down. In terms of Service Fabric cluster, it's Service Fabric's responsibility to make sure that your VMs, your instances, part of the node type, will be deployed in different racks, so that if some part of the hardware goes down, any other VM will still be available. And it's the availability set which actually makes your virtual machine scale set, and thus indirectly or directly, actually, the entire Service Fabric cluster be highly available and offer SLA as well. Now, Besides the availability set, there's a more technical concept of the update domain and the full domain I was telling you about earlier. Now, by default, you will always have 3 full domains and 5 update domains, and that number can actually be increased up to 20. The idea is to isolate virtual machines from upgrades and to isolate in the case of update domains, and to isolate virtual machines from failures in the case of full domains. Within an availability set, you can have up to 100 virtual machines, which should be more than enough for any known scenario and any known cluster. When you're looking at the cluster map inside the dashboard, these are images from the dashboard again. Your individual nodes will be represented part of this chart, where on columns or vertically, the full domains will be represented. So you have full domain 0, full domain 1, full domain 2, full domain 3, and full domain 4 for this particular scenario. And then you have 5 different upgrade domains or update domains on the horizontal lines as well. If you only have 5 nodes in total, that means that each node will be on individual full domains and upgrade domains. So any new upgrade will force the system to upgrade, or any new upgrade of an application will force the system to deploy the application one after the other, and so on and so forth. Should you have 2 extra nodes? Obviously, some other 2 nodes, in this case, on the right-hand side of the slide, you'll have in full domain 0, the same 2 nodes part of the full domain. So if the entire rack part of the full domain 0 goes down, unfortunately, 2 nodes will go down. But at least at the end of the day, you still know that your application is highly available and it still runs with no downtime whatsoever. If you're doing an update, whilst the first node is still part of its same individual upgrade domain, namely 0, the upgrade domain 1 will force 2 nodes to be simultaneously updated with the newer version of the service or the application. Now, there are a lot of service types, and most importantly, there's a stateful state. Why do I consider that so important? Because at the end of the of my journey with Azure, one of the best practices people were telling me about, especially at Microsoft, besides the transient fault handling one, was always make sure that your web services are stateless. Make sure that you're not using temp data. Make sure that you're not using session. Make sure that you don't call out the session manager anymore. And if you do have to call that session manager within your ASP.NET applications, use a centralized one rather than the improc one. Because otherwise, once you scale out your application, you will end up in problems. That is no longer true. It was sort of worked around by using the AR Fenty back in the day, but that was also performance impact. Nowadays, with Service Fabric, you can easily have stateful applications. The idea of a stateful service and a stateful application which runs within the Service Fabric is to no longer have remote calls to remote persistency systems, systems which store data, such as SQL database, such as Redis cache, and this and that. You want to minimize the number of network hops. And that means that if there is a way to store the hot data, the data which your services are actively using, very close to your compute, you should do that. And there is where stateful services come in. Now, in terms of stateless services, however, you also get the concept of a guest executable. So a stateless service at the end of the day is a new service you will create, but it can also be an exe file which you already have. And on top of that, for a few months already, Service Fabric is also offering the option of running containers. So basically, within Visual Studio, for example, when you're developing your Service Fabric application, you will just specify the container image. And then it's Service Fabric's responsibility to make sure that it downloads that container image and it runs a new container based on that image. Now, you might be asking yourself, why would it do that? And you know why? Because of the entire orchestration thing you want to have. You want to have a primary, you want to have a secondary, you want to have those containers up and running in no time. And if the node goes down, it's no longer a matter of deploying binaries around an artifact. It's only a matter of download the image if it's not already on the node, which will probably not be the case, and just make sure you run the new container. And those containers are Docker format based. So that means Windows containers or Linux Docker containers for the Linux world. Now, that sounds good. But you know what's the best thing of it? It actually acts as an orchestrator, because Service Fabric offers you the discovery services, which give you more information into what ports can use, what are the ports in the individual nodes. And because you will always have, in the case of stateless services, always a single primary and multiple secondaries, there will always be a single node listening. Now, there's an entire communication pipeline, and unfortunately, there's almost no time whatsoever now to go through that mechanism. But the idea is that when you deploy a stateless service, you're configuring an instance. There can be a fixed instance count, or there can just be one per node, which means you'll have one stateless service copied on all of the nodes part of the cluster. Do you create multiple nodes? Awesome. You can just copy or have Service Fabric automatically copy new instances of your services. In this application right here, we have our front end called the web app, and we have the web API, both being stateless services and both copied across the entire cluster on all the nodes. Now, should a new node be created, Service Fabric will make sure that automatically and automagically, I would say, it just copies the stateless services on that new node as well. Now, there are a lot of other types of applications you can create. They don't have to be websites or web APIs, RESTful services. You can even have cloud services. Remember the cloud services or the hosted services I was telling you about? The one which is a platform as a service offering and offers you the web and the worker roles? That itself can be a stateless service. Or any other program that does not require state and a container does, will and can be a stateless service within Service Fabric. The communication, as I was telling you about, there will always be a unique URL with one or many ports available for that service. Now, Service Fabric can share ports on the same nodes so that multiple services can all use the same port as long as they have the unique URL. So as an example, there would be a base address, which is consisted of the application name or the application type and the service type. And then you have your online store and column 443 if your service should be listening on that port. And it's Service Fabric's responsibility to make sure that any incoming request to your online store column 443 on port 443 will be redirected to the actual primary. So you don't have to know any IP addresses or private IP addresses even of your primaries and your secondaries. You don't have to keep a chart or a table of that. It's the entire communication mechanism in Service Fabric which takes care of that. Now, when it comes to running containers in Service Fabric, though, the idea is that Service Fabric can also deploy services in container, and you can mix services in processes and services in containers in the same application. Why is this cool? Because just think of it. You may have started your journey with Docker, with Kubernetes. And by the way, if you didn't, just know that it takes probably a full day to correctly install a Kubernetes orchestrator. What about the Service Fabric cluster? It's only a matter of seconds, I would say, to correctly choose the inputs and then just wait for the cluster to be deployed in 15 minutes, maybe in Azure. If you want to run it locally, you can obviously create for development purposes, even download the SDK, install everything, and you will simulate 5 nodes on your own machine just to make sure that you get a concept and your application is running correctly. Now, once you do that, you will have whatever stateful or stateless application you want. But as I was saying, if you already started your journey with Docker and you already containerized your application, why not use Service Fabric as an orchestrator? Use the image you already have, and if there's some parts of your application which you were unable to containerize because you are still dependent on some operating system libraries or some binaries which you didn't want to copy over part of the container image, no problem. Problem almost solved. Just run that as a process, part of the Service Fabric offering inside your Windows-based operating system. Now, the support for containers, as I was saying, is both Docker containers on Linux or Windows containers. And it even supports the Hyper-V isolation model, which is kind of a mind-blowing fact if you think about it. Again, it's an orchestrator, but at the end of the day, it's more than just an orchestrator. It's also a platform for developing new apps. And when you develop new apps, you just deploy those artifacts to the application. It doesn't have anything to do with Hyper-V. And yet, if you want to use it as an orchestrator, there is no flag, there is no configuration to do so. There is just the concept of configuring and defining the manifest of the service, which specify, hey, this is a container, and hey, I want to use the Hyper-V isolation model. period. Pretty easy. Now, in terms of stateful applications or stateful services, there's also the concept of partitions. And the idea of a partition is to strip across the available nodes your data. In this particular example right here, even though it might not be that obvious, I'm using some hashed calculated values to make sure that when I am adding any new data, I'm more or less evenly distributing the data across the entire cluster and different nodes. So I would have the EDA, E4C, 5P, whatever. Basically, because I have one service on the 5 different nodes, and I do have all those partitions created, I end up creating so many strips as the number of nodes I have and as the number of partitions I have defined. So each partition will have its unique address, its unique state, and the replica. And the concept of a replica basically assures that if the node does go down, the data is still available on other nodes. Now, adding additional nodes will rebalance the existing partitions, and more partitions basically mean more scale. So as I was saying, the concept and the entire idea of a stateful application is just to make sure that you don't have to go across so many network hops and don't have to do some unnecessary authentication just because the persistency system is a remote one. Instead, you can use a stateful service, which is only accessible from within the cluster or only accessible from within your own application type. You can configure that. You can do that in development, and then you'll have the best performance of gathering the data. But you still want to make sure that your data is and has the biggest scale possible, and that's why you use partitions. You're just stripping across the entire set of nodes you have available rather than just copy the data, the same data over everywhere. If you have a new partition created, you're just moving partitions around. And again, remember the concept of replicas. So if the one node will ever go down, you still will have the data available because of the replicas. Now, on top of those concepts is also the idea of reliable state. There is a state manager which Service Fabric provides, which is just an object for stateful services to be utilized or to utilize. The stateful service can access a reliable collection, which can store and retrieve persistent state that automatically replicates to all the secondary replicas in the same partition. Sounds complicated, but it really isn't. Basically, there are two types of state or state objects you can store, besides everything we've talked about so far. There's the reliable dictionary, which is just a dictionary at the end of the day, but a reliable one. And then there's a reliable queue as well, when you want to do queue messaging and asynchronous messaging patterns. Now, your reliable dictionary will be a key value-based collection of data, which provides just a location for you to store objects which you want to be durably persisted across replicas and restore if a failure does occur. Now, you will always have, and this is not the best practice, but kind of, if you don't do it, don't expect the application to be good. You have to wrap all your code in transactions. And this is a cool and interesting concept, because now even though you have a distributed system, at the end of the day, Service Fabric is just a distributed system, you still have the concept of an atomic transaction. Atomic, meaning that if something doesn't go through completely, any partial write, any partial read, anything like that will not be considered. Now, all methods will be and are asynchronous, and they do not implement IReliable. Instead, you will have to use another interface called async enumerable when it comes to the reliable dictionary if you want to enumerate through your dictionary. The use of transaction is very well documented online. I will not cover it in too much detail. The idea is that you can just use something called an iTransaction interface object or type of object. And that comes from the response of a create transaction method from your state manager, which I was telling you about earlier. Within the transaction, you should do any copies, any move of data, any sets, any gets. And when you're done, just make sure that you close the transaction and you are safe to have a reliable data persisted. Now, the reliable queue, on the other hand, is just a durable queue, which can store messages that you want durably persisted across replicas and restored again after a failure. In this case, obviously, you still have to use transactions, and all the methods, again, will be asynchronous. The reliable collections as a concept basically provides you a data store, which is replicated within partitions and not across the entire application. And that is important because the idea for using partitions, again, is just to make sure that you have very good performance. The idea of using replicas is just to make sure that if something goes down, a node or a couple of nodes, you still have the data and no data is ever lost. The data stored in one partition will not be accessible from a different partition. Good. This basically concludes our conversation now about Service Fabric. It has been a great opportunity, I would say, to get a better understanding on what Service Fabric is. And make sure that you check out Obsolety courses and the Obsolety course catalog to learn more about Service Fabric, about Azure, and any other Microsoft-related products. Thank you so much. It has been Alex Mang. It was my pleasure.